In this video, we will look at composing functions or composition of functions. So if I looked at the general case f comp g of x, it's actually equal to f of g of x. And so I think of f as my outer shell, and so I say f of g of x, and I'm sticking g inside of f. And so, if I was to flip it around, I'd say g comp f of x. So this is g compose f, or g comp f of x, so g of f of x. That's how I would write that. And I actually like to write it that stage first, and then you'll see what the input one is and which one's the outer shell. So in this case, g is the outer shell, and I'm sticking f of x inside of g. Basically, you're going to replace your variable with your f of x function, the entire function, and you can put a function within a function, and you end up with a function output. The domain is I won't ask you for domain or range, but if you're listening and you want to know how do I find the domain of a composed function, the domain of say f comp g of x would be the domain, the intersection of the domain of the g of x intersected with the overall answer. So you can't plug in anything that wouldn't work anyways with g of x and then the intersection of the overall answer. But I'm not going to ask you for the domain of the composition functions. But anyways, if I look at this example, this is example 3 of g through I in the chapter 12 practice test. If I give you two functions, and the two functions were f of x equals x squared minus 1 and g of x equals 3x plus 2, let's find the following, and we'll simplify these. So f comp g of x. F comp g of x really means f of g of x. So notice that I highlighted this in red. G of x is my input value, but f is my outer shell. So I look up to f, and I see that f of whatever equals whatever squared minus 1. So I'm going to do the same thing here. I'm going to say f of whatever is my whatever squared minus 1. The whatever I'm putting in there is the entire g function, which is 3x plus 2. So I'm basically replacing x with the whole g function of 3x plus 2. And then now you'll expand that out, 3x plus 2 times 3x plus 2, and simplify it down, and you should end up with 9x squared plus 12x plus 3 when you simplify like terms. Now I could ask you, what is f comp g of 1? If I ask you that was a numeric value to plug in, that's really the same thing as saying f of g of 1. I could do this two ways. I could actually just plug in 1 into my g function to get an answer, right? Because f of g of 1, what you do is you just basically take the 1, plug it into this, get an answer, plug it into this, and you can keep going. Backwards, it always works this way. Or think of it as this is f of g of 1. Find out what g of 1 is first. G of 1 is going to be 3 times 1 plus 2, so it's going to be 5. Now that I got that answer is 5, now plug 5 into your f. F is your outer shell. You plug 5 into this. 5 squared minus 1 should be 24. That's a way to do it, if I say, especially if I didn't ask you to find the general case of f comp g of x. But if I did ask you to find the general case of that, you could actually just take the 1 and plug it into the x and the f comp g of x. It's for all of them. So 9 times 1 squared is 9, plus 12 would be what, 21, plus 3 is 24. You get the same answer. But it's nice if I just ask you a numeric example like that, write it as f of g of x, plug the 1 into your g, then get that answer, and then plug it into your f. You work backwards, dumping it in, get your answer, dump it in. If you have more compositions like h of f of g, take that answer and dump it in and keep working that way. The last example is, what if I ask you g comp f of x? Well, now g is the outer shell, and f is going to be my input, my function I'm going to stick inside of g. So the outer shell of g says, well, 3 times whatever plus 2. So I'm going to say 3 times whatever plus 2, and the whatever is my whole f of x function, so I'll replace that. Now I'll distribute my 3 through and combine my like terms, and I should end up getting 3x squared minus 1. So that's composing functions, and so you'll see there's other examples on the other handouts that you can kind of look at how we work through those.